Our next one we're going to look at is number 12. 53% as well. Number 12. Number 12 is also 53%. It says this. Which function has a removable discontinuity at x equals 2? All right, quickly on the side here. Infinite discontinuities. Just go out that way. It's down the hall that way. Yep. All right, let's say if it was infinite, it would look like this. That's infinite. I want to remind you what these look like. That's infinite, where the graph at 2 would be breaking and going to infinities. I did not draw the bottom side very well. It would go flat line like that. That would be infinite. Okay? If it looked like jump, at 2, you would see some type of graph where there's an open circle and a closed circle. Typically, it would look like that, something similar like that. That's jump. Okay? We are looking for removable, which when you originally graph, what a removable will look like is it'll look continuous until you actually click the graph at 2. And once you click it, you will actually see at that moment when you click it, it'll then show you that there's an open circle. Okay, so that's the idea what you're looking for. To kind of speed you up here, is we're looking only at x equals 2. So let's go through these and graph them. Number 1, how do I graph this piecewise function? That's what it means when you see a squiggly like that. How do you graph piecewise? You move the squiggly to either the comma or it could be an if as well. You're going to actually put your squigglies here. And the way to do it, Desmos, the easiest way, I should say, is to do this as 2 separate lines. So, and I'm going to ignore the front end. So for that reason, I'm going to cover it up. I'm going to ignore the f of x equals, and I'm just going to type in that portion right there. And so we have 3x minus 1 squiggly. X is, and I'll just use Desmos keyboard, less than or equal to 2. And then I have x squared, squiggly, where x is greater than 2. Okay, which type of that is a break at 2. There is a break in this graph. It's not continuous. What type of break is that?
A jump.
That would be a jump. It jumps from one y value at a y value of 5 to the y value of 4. I know it says undefined, but that has a y value of 4. That's how far it jumps. It jumps 1 unit. So that would be a jump. A is a jump at x equals 2. Jump discontinuity. I'm just going to say disk at x equals 2. Is that what we're wanting? A jump? No. A is out. So now we look at B. B says f of x equals x squared plus 2x over x squared minus 4. What? Well, graph the denominator because it's discontinuities. That's great. The denominator will tell us where the breaks occur. But when you check out this one, what's happening at 2? That's infinite. This one's going to be an infinite at x equals 2. But I will go back, since I accidentally graphed the denominator, I will show you this. An infinite discontinuity at x equals 2. So it's out. It's not correct. But check this out. This is kind of cool. I graphed the denominator. So think, anytime you have to do domain or discontinuities, you can use the denominator. The denominator, those d's go together. The denominators, you're not allowed to divide by 0. This tells you, graphing the denominator, there are 2 places the denominator will equal 0, -2 and 2. So that could inform you where to check this graph if you had to just find the discontinuities. This has a break at -2. You can see it does have a removable, but it's at -2. That's not what we need. This does have a removable at -2, but not at +2. So I'll go ahead and add that on there. And removable at x equals -2. But that's not what we needed. We needed +2. So now I'm going to try C. F of x equals x minus 2 over x squared minus 9. I'm looking at 2. Here's 2. It's a closed dot. Is that a removable? No, this is continuous at x equals 2. This does happen to have 2 breaks, But this one is continuous at x equals 2. A solid dot means it's continuous. Like that. This graph does not even break at 2. It does have 2 discontinuities. What types are these called? These breaks. Infinite. There's infinites at x equals 3, it looks like. 1, 2, 3. And infinite at negative 1, 2, negative 3. So you could add that as well. And infinite at x equals negative 3 and positive 3, which means that one's out. So the correct answer must be D. Let's go confirm. So we think it's going to be D. Let's go to D here. F of x equals x squared plus 2x minus 8 all over x squared minus 2x. So I see there's an infinite at the x value is 0, but we're not concerned about 0. We're looking at 2. So I'm going to click on my graph at 2. What does it do at 2? See how it's open circle? Otherwise, it looked continuous until we clicked it. And then we found, no, wait, it's not continuous at 2. It is removable. So this is removable at 2. It also has infinite at 0 for the record. It did have an infinite at x equals 0. And you could, if you had to find all of them or know where they all are, you could, again, if you graph the denominator, this denominator will show you that it has 2 breaks. It's 0 and 2. 0 and 2, like we found. The 0 was an infinite. The 2 was a removable right there. Removable. Yep. So that's number 12.